Hi everyone, this is Baiju Vasudevan. Welcome to my channel pibyme. Today we are going to learn chapter 1 from Pure Mathematics 1. As you can see, this chapter has 6 subtopics, 1.1 all the way to 1.6. I am going to combine subtopics 1.1 and 1.4 because they both are basically dealing with indices. So 1.1 and 1.4, 1.1 and 1.4 from chapter 1. Laws of, you need to know basic laws of indices, which you might have learned in your lower grade. The laws of indices, a to the power m times a to the power n is a to the power m plus n. And if it is division, you can write it as a to the power m minus n. The basic laws of indices. And if you have a to the power m to the power n, you can write it as a to the power, they got multiplied. You can multiply these two exponents. These are basic laws of indices. And in 1.4, you have to learn fractional indices and negative indices. When I say fractional indices, let's say you have 1 upon number 4, 1 upon a to the power m. You can write it as a to the power minus m. Or sometimes you will be dealing with mth root of a. Mth root of a. These two are different. This is m times square root of a. M times square root of a. M is being multiplied by this square root of a. This, as you can see, a little m up there, that means mth root of a. If there is no number, it is just a square root. It means like it's 2, the square root. If you have like 3 or some other number, you can write it as a to the power 1 upon m. Mth root of a is a to the power 1 upon m. And if you have mth root, of a to the power n, you can write it as a to the power n to the power 1 upon n. This whole thing, whatever is in there, to the power 1 upon m. But again, when you apply these laws of indices, you can just multiply them, m times n. So when you multiply here, it will become a to the power n upon n. And what else? Okay, you need to know anything to the power 0 is 1. Anything to the power 0 is 1. That's all. These are all the basic laws of indices which you need to be aware of. Now, if you take a look at your exercise 1.1a, you can see like basic simplification involving all these laws of indices. So I'm going to pick few questions from exercise 1a and I'm going to show you how to simplify them using the laws of indices. So you need to memorize all this. You can add one more also, which is ab to the power m. If you have two numbers in multiplication and whole to the power m, you can write it as a to the power m times b to the power m. Same goes for division also. A upon b to the power m is a to the power m divided by b to the power m. So let's see how all these laws of indices can be applied when it comes to simplification of algebraic expressions. How do we simplify these using laws of indices? You always need to look for a common factor. So here you can look for a common factor. If you take 2 out of this, you will be left with 3x to the power 4 plus 5x to the power 6 divided by 2x. So you can cancel out 2. Again, there is a x also. You can take out x to the power 4 as a common factor or x as a common factor. So if you take x as a common factor, it will become x times 3x cubed plus 5x squared divided by x. and cancel out. So your answer is 3x cubed plus 5x squared. This is an easy one, and again you can't expect this type of easy questions in your exam. This is for you to practice. So always look for a common factor and cancel out. Sometimes I notice students, they do this. Like let's say you have x square plus 3x to the power 5 divided by x squared. You are not allowed to cancel this. You are not allowed to. That's a very big blunder. When you want to cancel something from the numerator to the denominator, you want to cancel out some common factors. The term that you want to cancel out must be in multiplication with all other terms in the numerator or in the denominator. When I say multiplication, you can see here that 2 is in multiplication with all other terms. That means that 2 is a common term here. It is common for all the rest of the terms. Here this 2 also in multiplication with all other terms here. That is only one term, x. So you can cancel. But here the x square is fine, but this x square is in addition with another term. If it is in addition or subtraction, which means it's not a common term. This term is combined with another term. But if you have something like this, if you have something like x square times 3 plus something like this, this x square is a common term because you need to multiply this by both the terms. So this is a common term, or in other words, this term is in multiplication with the rest of the terms. So you can cancel this. Same goes for denominator also. Denominator, let's say you have x square plus 4 here. X square plus 4. You are not supposed to cancel this because this x square is not a common term in the denominator. So you need to be very careful. Whenever you want to strike something out, make sure the term is a common term. Here 2 is a common term, 2 is a common term. Here same goes for x. So this is a basic simplification. Let's move on to question number 2. Now question number 2, you are given this cube root of x. Cube root of x can be written as x to the power 1 upon 3 divided by square root of x, which is x to the power 1 upon 2 whole square. So our laws of indices says you can put the power 2 for each and every term. So you can write it as x to the power 1 by 3 whole square, x to the power 1 by 2 whole square. Again the law says you can multiply them. Here also when you multiply them, your 2 will be cancelled. So your denominator will be x to the power 1 or x. Here it will become x to the power 2 upon 3. Now bring this x to the numerator, x to the power 1 to the numerator. So it becomes x to the power 2 by 3 minus 1, which is 2 minus 3 is minus 1, x to the power minus 1 upon 3. X to the power 2 minus 3, which is minus 1 by 3. Or you can write it as 1 upon x to the power 1 by 3. That's your answer. Or you can write 1 upon cube root of x, which is the same as x to the power 1 by 3. 25 upon 16 to the power 3 by 2. Sometimes you can see a minus 3 by 2. Let's say the same question, you have minus 3 by 2. You flip them, write it as 16 upon 25 and change the sign to positive. What I'm doing here is again laws of indices. When this term, we learn this 1 upon 8 to the power m is 8 to the power minus m. So that means when you bring the denominator to numerator, you need to change the sign. Let's say you have minus m here. You can write it as positive m. So when the 16 comes to the top, becomes positive 3 by 2. 25 goes to the bottom, again positive 3 by 2. That's why whenever you see a negative sign there in the exponent, you can just flip the fraction and change it to positive. It will be easy. So this question is taken from exercise 1B, if I'm not wrong. So how do we simplify this? Write this 3 by 2 for both the numerator and denominator. 25 to the power 3 by 2, 16 to the power 3 by 2. So you can write it as 25 to the power half whole cube, which is same as 25 to the power 3 by 2. I write it as 3 times half. So I brought this half inside because we know 25 is a square number. So you can find the square root of 25. Same for 16. 16 to the power half whole cube. So 25, square root of 25 is 5. 5 cube upon 4 cube, which is 25 times 5, which is 125, divided by 4 cube. 4 times 4 times 4, 16 times 4 is 40, 64. That's the answer. So this is how we simplify. You can expect this type of questions. You need to be very careful when you're dealing with fractional or negative indices. Okay, look at this question. This question has been taken from Pearson Edexcel specimen paper released on September 2018. You are given 3 to the power minus 1.5 is 8 times root 3. 8 times root 3. Find A. This question has 2 marks. How do we do that? The easier way is make A as the subject. So when you make A as the subject, you can write it as 3 to the power minus half divided by root 3 and simplify it. That's it. How do we simplify it? You can write it as A is 3 to the power minus half. You apply the laws of indices, minus 1.5. This 3 to the power half, that means 3 to the power 0.5. When you bring it to numerator, it becomes minus 0.5, because that's what the laws of indices says. And you combine them, you will have 3 to the power minus 2, which is 1 upon 3 square or 1 upon 9. So your A is 1 upon 9. One of my students asked me, can I leave it here instead of, because I think this is a lot of hassle, so can I just leave it here 3 to the power minus 2? No, you are not supposed to leave it here because it has a negative exponent and it can be simplified. You always need to write your answer in the simplified form. Your A is 1 upon 9. You have 2 marks for this question. And let's move on to part B. You need to simplify this. In part B, you are given this algebraic fraction and you need to simplify this question as 3 marks. Again, this also from the specimen paper. How do we simplify this? Put this exponent 3, power 3 for each and every term. So it will become 2 cube times x to the power 3 upon 2, because you can just multiply them, divided by 4 x square. That's it. 2 cube is 8. You can cancel 8 and 4. 2 4s are 8. So 2 x to the power 3 by 2 minus 2. When I bring this x to the power 2 up there, by applying laws of indices, you can write it as minus 2. It will become 2 times x to the power minus half. 4, 3 minus 4, minus half. Again, do not leave it here. You can write it as 2 divided by x to the power half, or 2 divided by square root of x. This is the most simplified form. So if you do this, you can get 3 marks. Okay, I have taken another question from January 2020 paper. This question has 3 subdivisions, and each question, the first question has only 1 mark, and this has 2 marks, another 2 marks. You can expect this type of question in your exam. You are given y is 3 to the power x, and they want you to express all these terms in terms of y. You need to change all the x's to y. How are you going to sneak in this y in there? Change this term, the given term, in terms of y. This question has only 1 mark, so it's going to be very easy. You can write it as 3 to the power x whole cube. because 3 to the power 3x is 3 to the power x whole cube. 3 to the power x is y. So you can write it as y cube. That's it. You got one mark already. Let's move on to number B, part B. You have 1 upon 3 to the power x minus 2, not 3 to the power x, so that you can replace it by y. You have 3 to the power x minus 2. Split them. When you split them, it becomes 1 upon 3 to the power x times 3 to the power minus 2. That's what your laws of indices says. If you have a to the power m times a to the power n, you can add them. Or if you have minus n here, you can subtract. Because basically this is same as this. So you split them first, replace 3 to the power x by y and simplify. So 3 to the power x by y, so it becomes, bring this 3 to the power 2 to the denominator, minus 2 to the denominator, it becomes 3 to the power positive 2 upon 3 to the power x, which is same as y. So 3 square by y, 9 upon y. So you scored 2 marks for this. Move on to C. C again, 2 marks again. You have 81 upon 9 square minus 9 to the power 2 minus 3x. Split them again. Write it as 81 divided by 9 to the power 2 times 9 to the power minus 3x. That's the first step you do. 9 square is 81, you can cancel out. And you are left with 9 to the power minus 3x. Bring it to the numerator. 9 to the power positive 3x. Now look at it. Look at this. 9 to the power 3x. You need to sneak this y into the term 9 to the power 3x. But y is 3 to the power x. It is not 9 to the power x. So the base supposed to be 3, not 9. So try to write 9 in terms of 3. You can write it as 3 square to the power 3x. And then multiply them 3 to the power 6x. 2 times 3x, 6x. Again applying laws of indices. Write it as 3 to the power x to the power 6. Because our objective is we need to find 3 to the power x so that we can replace it by y. So now when you replace this by y, you get y to the power 6. So you got total of 5 marks from this one. It's an easy mark actually. You need to be very careful when you are dealing with negative or fractional indices. So this question is from January 2020 paper. This question number 6, has been taken from Jan 2019 Pearson paper. This question has 3 marks. You are given this equation, 3 to the power x divided by 3 to the power 4y equals 27 root 3. You need to find y in terms of x. So how do we do that? You have a base 3 here. So you can write it as 3 to the power, bring this up here, x minus 4y equals. Since you have a base as 3, try to write this, the term on your right hand side as a base of 3. So you can write 27 as 3 cube, square root of 3 as 3 to the power half. So you can write 3 to the power x minus 4y equals, when you add them, 3 to the power 3 plus half, which is 3.5. That's it. You got both sides the same base, so you can just equate the exponents. X minus 4y is 3.5. Now find y, you will get y in terms of x. That's it. You got 3 marks. Put this y here, 3.5 here. X minus 3.5 is 4y. So your y will be x upon 4 minus 3.5 upon 4. That's it. This is your solution. If you want to cancel the decimal, you can multiply and divide by 2. So it will become 7 upon 8. But you don't need to do that. You can just leave it like this. This question is from Jan 2019 paper, easy 3 marks. So we are done with subtopics 1.1 and 1.4. Let's move on to the next one, 1.2 and 1.3 combined, because they both are dealing with removing brackets and simplifying or factorizing the algebraic expressions. So what you can expect in these two topics, 1.2 and 1.3? Simplifying algebraic expression. For example, let's say you have x minus 1 into x plus 2 into x minus 3, let's say. You need to remove brackets and simplify them. So how do we simplify this? Take any two of the term first, multiply them, then multiply the result with the third term. So when you multiply, then you take x and you multiply both, which will be x square plus 2x. Now take the minus 1 and multiply both. Here you need to be very careful, because I have noticed many students making this mistake. When they multiply the second term, I don't know why they miss out this sign. You need to, whenever you take a number or a term, a variable, you always take the number or the variable together with the sign. For example, here x, even though there is no sign here, it is a positive x. So we take positive x plus x and you multiply both. Here it's a minus 1, multiply minus 1 by both x and 2. So you will have minus x minus 2. And then x minus 3. You can either simplify and then multiply, or multiply first, later you can simplify. Take x, multiply everything. X cube, 2x square, minus x square, minus 2x. X times everything. Now take minus 3, again minus 3, not just 3. Minus 3 times everything. So minus 3x square, minus 6x, minus into minus plus 3x, minus 3 into minus 2 is plus 6. That's it. This is how the simplification works. Now, like, look for the like terms and simplify them. X cube, you don't have any other x cube. X square, you have x square here, 3 terms actually. So 2x square minus 4x square, minus 2x square. 2 minus 1 is 1, 1 minus 3 is minus 2. And then x term, x square, we are done with x square. X term, here 3 terms. So minus 2 minus 6 is minus 8, minus 8 plus 3 is minus 5x. And we are left with plus 6, that's all. So this is how we remove the brackets and simplify. Sometimes you may get questions like this. 2x minus 3y whole cube. 2x minus 3y whole cube. How do you expand this? They want you to expand this by removing brackets. If you know the formula, the algebraic identity is a minus b whole cube. It is much better. Even if you don't know, you don't need to worry about it. You can write it as 3 terms. 2x minus 3y into 2x minus 3y into 2x minus 3y. Write it 3 times, and same like this. First take first 2 terms, multiply, then the third term. But since we are in A level, you need to know, if it will be better if you learn these algebraic identities. Same like a plus b whole square and a minus b whole square. You can learn this algebraic identity, a plus b whole cube, which is a cube, and here b cube, and in between there are another 2 terms, 3a square b, 3ab square. This is algebraic identity, a plus b whole cube. So if you want a minus b whole cube, replace b by minus b here. So a cube, when you replace b by minus b, the whole term becomes minus. Here minus b whole square is still positive, so leave it as it is. Minus b whole cube is minus b. This is algebraic identity. You can use this. This will make your life much easier. You have a minus b whole cube. So a cube, a is 2x, b is not minus 3y, b is just 3y. B is just 3. If you want to apply the first one, take b as minus 3y. Up to you how you want to do that. A cube minus 3a square b plus 3a b square minus b cube. That's it. This is much easier. So 8x cube, and you need to multiply everything here. 2 square is 4. 4 times 9 is minus 36 x squared y, plus here you will have 2 times 3 is 6. 3 square is 9. 9 times 6, 54 xy square. And minus 3 cube is 27y cube. That's it. You don't need to do all these steps multiplying, because I'm worried that when we multiply, you need to be very careful. If you make a little mistake, a negative sign, you miss out a negative sign, everything will be wrong. So if I were you, I will always go for this algebraic identity, which is much easy. From here, I skip this step, substitute AB here, and I got my answer already. When you multiply, you can use your calculator and verify whether it's correct. 9 times 4, 36. 6 times 9, 54. 3 cube is 9 3s are 27. That's it. So this is how you remove bracket and simplify. Sometimes you need to add bracket. When I say add bracket, you need to factorize the given term. So pay attention to your question. When they say factorize, you have to factorize it. When the question says simplify, you need to remove the brackets and simplify. Okay, question number 3, they want you to factorize this. So that means we need to factorize and add brackets. So look for the common term. This can be divided by 4. This also. So 4 is a common factor. Take 4 out. So you will be left with 3x squared y plus 2x y squared. So 4 is a common factor. And again, look for the common factors in the variable as well. You have x squared x. So you can take 1x out and you can take 1y out. So you'll be left with 3x here. Here this x has been taken out and even a y. So you are left with 2y. That's it. Some students, they do this. They write this number as a prime factors, like 3 times 4 times x times y, plus this 8 also prime factors, 2 times 4. 4 is not a prime, but like since you have 4, you can write it as 2 times 4. X times y. And then take out common factors. 4 is a common factor, x is a common factor, and 1y is a common factor. So you are left with 3x here in the first term. Second term you have 2y. Up to you how you want to do that. But when they say factorize, you need to factorize completely. You are not supposed to leave any common factor here. You are not supposed to leave any. All the common factors should be taken out. You cannot write it as 4x into 3xy plus 2y squared. This is not going to get you full marks, because there is one common factor is in there, still in there. The y is a common factor. It has to be taken out. So this is the fully factorized form. So apart from this, you can expect quadratic expression. This is a quadratic function. They want you to factorize this quadratic function. So you need to know the product sum rule, the product sum method, how to factorize this. Your A is 6, B is minus 10, C is 4. Take B and AC. B is minus 10. AC, multiply A times C. 6 times 4, 24. So you need to look for two numbers which are added to minus 10 and multiplied to 24. It's not 6 and 4 because 6 and 4 when you add them you don't get minus 10. So it's supposed to be minus 6 minus 4. Because when you multiply them you get positive 24. So you split them, split the middle term minus 10x using these two numbers, minus 6x minus 4x plus 4. Now factorize. Take the first two terms, look for the common factor 6x. So you are left with x minus 1. Here you are supposed to have x minus 1, so take minus 4 out. So 6x minus 4 and x minus 1. This is how you factorize the given quadratic expression, quadratic function, by using product sum rule. Or you can do one more thing. You are allowed to use your scientific calculator. If you go to the calculator mode and look for equation and second degree equation or equation in this form, ax square plus bx plus c, it will ask you to key in the values of a, b and c, which are a is 6, b is minus 10, c is 4. When you key in and press equal, you will get two values, x1 and x2. So for this particular equation, when you try this using your calculator, you will get two values, x1 1 and x2 2 upon 3. That means your calculator basically giving you the two solutions of the equation 6x square minus 10x plus 4 equals 0. That means the two values, two roots of this equation. So how do you form this factorized form using these two numbers? So write it as, bring this 1 here, so it will become x minus 1. Here, instead of bringing the fraction, bring the 3 here first, 3x and minus 2. So you got 3x minus 2. So you got two factors already, x minus 1 and 3x minus 2. And when you look at this equation, it's 6x squared. When you try to multiply them, you get only 3x squared. It's supposed to be 6x squared. So multiply either one of these factors by 2. You can either multiply this or this, up to you. You can write it as 2x minus 2 into 3x minus 2. This is also a factor. Or you can write it as x minus 1 into, multiply this by 2, 6x minus 4, which is same as this. But do not multiply the first one because it is not a factorized form. Again you need to take 2 as a common factor here. So this will be the factorized form. You can do that. Or learn the product sum method. Learn how to simplify. Take b and multiply a by c, then find two numbers which are added to minus 10, multiply to 24 and then factorize it. So you need to learn this also. But again I came across another interesting question. They want you to factorize this cubic expression, cubic function. So take a look at it. It has a common term x in each and every term. So when you take x out, you will be left with 6x squared plus 7x plus 5. Take x as a common factor. Now this is nothing but a quadratic expression. You can factorize it by using product sum method. So when you factorize it, you will get other two factors, which I am not going to do it now. You can try, but this is how you simplify this. First take x out, you are left with quadratic expression. Then factorize the quadratic expression using product sum method. There is this one more question, 4x to the power 4 minus 13x squared plus 9. They want you to factorize this equation, and we have no idea how to factorize an expression with the degree 4. Fourth degree function. We don't know how to factorize this. But again, when you take a look at it, if you replace x square by some other term, take x square as y. So your x to the power 4 will be y square. Hope you understand this. X square, replace x square by y. X to the power 4 by y square. You will have 4y square minus 13y plus 9, which is a quadratic expression in y. When you solve this, you can factorize this by using product sum method. Take b and ac. Your b is the coefficient of y. AC is 9 4s are 36. You need to find two numbers which are added to minus 13 and multiplied to 36, minus 9 and minus 4. Split the middle term using the two numbers. Now factorizing. So when you take y out as a common term, you are left with 4y minus 9. Here you are supposed to have 4y minus 9. So you take minus 1 now. So it will be 4y minus 9 into y minus 1. Is that our answer? No, because the given function is in terms of x, not in y. So you need to replace y by x square here. So you will have 4x square minus 9 into x square minus 1. Again, is this a final answer? No again, because you need to simplify, factorize these two factors again. How do we factorize this? There is one algebraic identity called a square minus b square is a plus b into a minus b. If you have a square minus b square, difference between two squares, you can write it as a plus b into a minus b. This is another thing you need to learn. So here, look at these two factors. First take 4x square minus 9. You can write it as 2x whole square minus 3 square. 4x square, right? 4 is a square number. You can write it as 2 square, and x square minus 9 also a square number. And here x square minus 1 is the same as 1 square. Why am I doing this? So that the term, forget about this. Look at the first term. It will look exactly like this, a square minus b square. You have a square minus b square. You can apply this identity. It will be a plus b into a minus b. Same goes for this. You have a square minus b square. So a plus b into a minus b. This is the next thing you need to learn. Difference between two squares. This is another algebraic identity. So this, I think this is the third one I'm telling you. The first one, a plus b whole cube, a minus b whole cube. Now a square minus b square. So this is the fully factorized form of the given expression. If you leave here, you won't get full mark. You need to factorize it. But again, what if the number here is not a square number? Let's say you have 4x square minus 5. What do you do? How do you write this as a square minus b square? You can write the 4x square as 2x whole square. But how about the 5? It's not a square number. Don't worry about it. Put it as square root of 5 whole square. Because square root of 5 whole square is 5. Now you can apply this identity, a plus b into a minus b. That's it. So these are all the things in that you need to learn from topics 1.2 and 1.3. basic simplification, basic factorization, and quadratic factorization, product sum method, and difference between two squares. Okay, look at these two questions. These two questions also from the subtopics 1.2 and 3. You are given x to the power 4 minus y to the power 4. They want you to fully factorize this. We know the algebraic identity for difference between two squares. So take it as x square whole square minus y square whole square. So it looks like a square minus b square. You can apply the algebraic identity a plus b into a minus b. A plus b into a minus b. This x square plus y square, you can't do anything, keep it as it is. But if it is a difference between squares, again you can apply the algebraic identities. You have a square minus b square. You can write it as a plus b into a minus b. This term, keep it as it is. That's all. This is how you factorize. Move on to question number 8. This is not difference between two squares, but the moment you take the common term x out, you are left with x square minus 64. 64 is a square number. You can write it as 8 square. So the factorized form is x plus 8 into x minus 8. So this is how you factorize. So we are done with subtopics 1.1 to 1.4. Now we are left with 1.5 and 1.6, and we are going to learn about surds. This is probably the first thing, a new thing that you are going to learn in this chapter 1. So what is a surd? 1.5 is basically about surds. 1.6 is rationalizing the denominator, which I will teach you in a while. A surd is a number, an irrational number, which is written in the form of square root. That means, like square root of 25. Is it a surd? No, because 25 is a square number. So if this number is not a square number, let's say 23, 24 or anything. If this number is not a square number, then you call this surd. So it is basically an irrational number. Basic operations, arithmetic operations on surds. How do we apply these basic operations? For example, let's say we have two surds, square root of 2 and square root of 7 times square root of 2 times square root of 7. When you want to multiply two surds, you can just multiply the number. Put a common square root. 2 times 7, 14. You are allowed to do that. Same goes for division. When you have, let's say, like square root of 6 upon square root of 2, you can write it as 6 divided by 2 is 3. You are allowed to do that. But when it comes to addition and subtraction, let's say you have square root of 2 plus square root of 7. Don't ever write square root of 9, which is not allowed. You cannot add them. You are not supposed to add them. Even same goes for, so this is wrong. Even same goes for subtraction. You are not supposed to, let's say square root of 7 minus square root of 2. You are not supposed to write square root of 5, which is wrong. So don't ever do that. So you need to keep this in mind. When it comes to multiplication and division, you can just put a common square root and just multiply the number. If there are 3 numbers, multiply all the 3 numbers. Now, how to simplify the surd? Let's say you have square root of 72. Let's say you have square root of 16. Square root of 16 is 4. We know that already. Square root of 16 is 4. Because you can write the 16 as 4 times 4. So when you have two numbers, same numbers, which are in multiplication, then you can take only one number out without the square root. So you can write it as 4. what we are doing here is basically laws of indices. You can write it as square root of 4 times square root of 4, which is 4 to the power half, 4 to the power half. So our laws of indices says you can add, if the base is same, you can add the exponent. Half plus half is 1, 4 to the power 1, which is 4. That's why square root of 16 is 4. So what I'm trying to say here, when you want to simplify, let's say you have square root of 32. You can write it as square root of 2 times 4 times 4. Because 4 4s are 16, 16 times 2, 32. Now, when you split them, you can write it as square root of 2, square root of 4, square root of 4, all in multiplication. So square root of 4 times square root of 4 is 4. You can't do anything with the square root of 2. So 4 root 2. This is how you simplify this. This is how you simplify this. So whenever you have something within the square root, break it down, break the number down into prime factors. Prime factors. So if you break it down into prime factors, 2 times 36 and 2 times 18, 2 times 9, 3, 3. So you break it down into prime factors and take a common number for two similar numbers. For 2 2's, you take 1 2 out, 2 3's, 1 3 out. So you will have 2 times 3 is 6, and you are left with another 2 here, 6 root. So this is how you simplify this surd. But if you have bigger numbers, it's going to be a waste of time writing them into prime factors. So if you're small, you can always look for two similar numbers, the bigger numbers. For example, square root of 72, right? Instead of writing them in prime factors, you can write it as 6 times 6, which is 36, times 2. 36 times 2, 72. So easier for you to take out the number 6. So your answer will be 6 root 2. Up to you how you want to break it down into prime factors? Yes, go ahead. Or you can do this also. So whenever you are given a surd, try to put them as a multiplication of numbers, like similar numbers. So you can simplify them. You can take one number, a common number for two similar numbers, only if they are in multiplication. Okay. So we are going to use this to simplify surds. So if you take a look at your exercise, okay, this question, they want you to simplify this. Whenever you want to simplify numbers involving surds, try to factorize the numbers. That's the first thing what you are going to do. You can write it as square root of 7 times 2 times 2, because 7 4s are 28, minus 2 square root of 9 times 7 is 63. So write it as 337 plus square root of 7 again. Okay. Now here for 2 2's, you can take 1 2 out. So you can write it as 2 square root of 7 minus 2. For 2 3's, take 1 3 out, and you are left with square root of 7 here plus square root of 7. And that's it. You have 2 square root of 7 minus 6 square root of 7 plus square root of 7. It's same like simplifying x. Let's say this is x. 2x minus 6x plus x, which is 3x minus 6x, which is minus 3x. That's it. This is how you simplify. So whenever you see a surd, an expression involving surds, try to break it down into prime factors and simplify them by taking out the common terms. Take one number for each two similar numbers. And then once you got all the like terms, it is an expression which involves a lot of surds. So look for like terms. So let's say you have like two more other terms. Like you have 2 square root of 7 minus 6 square root of 3 plus square root of 7 plus 2 square root of 3. Let's say you have this expression. You simplify the like terms. 2 root 7 plus root 7 is 3 square root of 7, and minus 6 plus 2 is minus 4 square root of 3. So always simplify the like terms. So you need to remember this. You have two surds which are in multiplication, you are allowed to multiply them. Even division, let's say you have something like this, square root of 72 upon, let's say, square root of 36. You can write it as square root of 2 times square root of 36 divided by square root of 36. You can cancel out. You are allowed to do that. So because when you multiply them, 2 times 36 is 72. You are allowed to do that. So just go through the exercise. There are a lot of several questions involving surds, like simple questions. But in your exam, you can expect mostly the questions from 1.6, rationalizing the denominator. What is that, rationalizing the denominator? You will be given a fraction. You will be given a fraction something like this, 1 upon square root of 11. This is a fraction, but the denominator is an irrational number because it's a surd. So you need to rationalize the denominator. That means you need to change the denominator to a rational number. That means basically you need to remove the bracket, square root. How do you do that? Take the same number, square root of 11, multiply both numerator and denominator by the same number. Because when you multiply and divide a fraction by the same number, the value won't change, value remains the same. 1 times square root of 11, here square root of 11 times square root of 11, the square root will be cancelled. This is what called rationalizing the denominator. The denominator, irrational number, becomes a rational number now. Even though the value change, it becomes a rational number now. This is what called rationalizing the denominator. No matter what your numerator has, it can be, let's say, let's take a look at another question. You have square root of 12 divided by square root of 156. They want you to rationalize the denominator. But before, you can just multiply and divide by square root of 156. You are allowed to do that. But you need to be you need to handle all these bigger numbers. So instead, first we cancel 12 and 156. Check whether there is a common factor. You can write it as 12. 156 can be written as 12, 3. So 1, 3. If I am not wrong, 13. Because 130 plus 26, 156. You can split this term into two terms. Square root of 12 times square root of 13. You can cancel this. 1 upon square root of 13. Is that our answer? No. This is a simplified form. But the denominator is a rational number. You need to convert the denominator into a rational number. It's an irrational number now. So how do we convert? Multiply and divide by square root of 13. So it becomes square root of 13 divided by 13. That's it. Even here, instead of 1, you have some other number. Let's say you have 7 root 2. How do we rationalize the denominator? Same. You take it as 7 root 2. Multiply and divide by the denominator. So here it will become 11. Here when you multiply only the term which are in square root. So 7, 2 times 11 is 22. So 7 root of 22. That's it. What if the denominator has some other number, something like this? Plus 3 or minus 3 or another term which are in addition or subtraction with this. How do we rationalize this? You have denominator, not only one surd, two surds connected by the arithmetic operation minus. How do we rationalize this denominator? When you have questions like this, it can be plus or minus, can be one third and another normal number, rational number. So what do? No matter what the numerator is, take the given fraction, root 3 minus square root of 2. Take a look at the denominator. You have square root of 3 minus square root of 2. It can be square root of 3 plus square root of 2 also sometimes. You take the opposite sign. If it is minus, take plus and multiply both numerator and denominator by square root of 3 plus 2. Okay, maybe I change this number just to avoid the confusion. Take it as 517. Because everything is 2 and 3. Maybe I'll change it to 5 and 7. Take a look at the denominator. Change the sign. If it is plus, take minus. Multiply both numerator and denominator by this number. So since you have minus, take plus. Square root of 3 plus 2, square root. Why are we doing this? Because our objective here is to make the denominator as a rational number. So when you multiply these two, it looks like a plus b into a minus b. We know algebraic identity says a plus b into a minus b is a square minus b square. So a square minus b square when you multiply these two. And numerator you need to take 5 and multiply both, and take square root of 7 and multiply. When you take square root of 5 and multiply both, you get square root of 15 and square root of 10. When you take minus square root of 7 and multiply both, you take minus square root of 7 and multiply both, you will have minus square root of 21 minus square root of 14. That's it. So square root of 3 whole square is 3. Square root of 2 whole square is 2. So 3 minus 2 is basically 1. So our denominator becomes a rational number now. That is the reason why we take the opposite sign of this and multiply both numerator and denominator. Our numerator can be anything. Just simplify this. When you simplify, you can write it as 3 times 5. Square root of, you cannot take any number out. So square root of 15 plus square root of 10 minus square root of 21 minus square root of 40. You cannot simplify this. You cannot simplify. Because even you write it as 3 times 5, it is inside the square root. Square root of 3 times 5, square root of 2 times 5. You can't do it. So your answer is square root of 15 plus square root of 10. Minus square root of 21 square root of 40. So what I'm trying to say here, your numerator can be anything. You multiply and if possible simplify. When I say if possible, let's say you have like the actual question was 2 and 3. Maybe when you multiply you will have some like terms where you can simplify them. So let's take a look at this question from May 2019 past paper. The part A, 1 upon 4 minus 2 square root of 2. You need to simplify this and write this in this form. 8 plus b root 2, where a and b are rational numbers. This question has 2 marks. So when you compare, you can see that you need to make these numbers rational numbers. That means you need to rationalize the denominator. So how do we rationalize? Take this fraction 4 minus 2 root 2. Multiply and divide by 4 plus 2 root. That's what we learned. 4 plus 2 root of 2. Take the opposite sign. If this is minus, take plus, multiply and divide. So 1 times this is the same. 4 plus 2 root 2. Here you have a plus b, a minus b. Use algebraic identities. A square minus b the whole square. B is 2 root 2. So when you square it, it becomes 4 square is 16 minus 2 root 2 whole square. So when you put the square on everything, 2 square root 2 square. Root 2 square is 2. 2 square is 4. 4 times 2 is 8. So this whole thing is 8. So 16 minus 8 is 8. So you can write it as 4 upon 8 plus 2 upon 8 root 2. You split them into two terms. 4 upon 8 is 1 by 2. 2 upon 8 is 1 by 4 root 2. When you compare this with this, you have a plus b root 2. Your a is 1 upon 2, b is 1 upon 4. Both are rational numbers. So you got the answer already. So this is how you rationalize the denominator. You got 2 marks for this question. Let's move on to part B. Okay, part B. You have 4x equals 2 root of 2x plus 20 root 2. You need to solve this. Write your answer in this form, p plus q root 2, where p and q are rational numbers. This question has 3 marks. So how do we find x? We need to make x as a subject. Put the term with x all to one side equals 20 root 2. So when you take x as a common factor, you have 4 minus 2 root 2 equals 20 root 2. So x is 20 root 2 divided by 4 minus 2 root 2. This is the value of x. But they are not interested in this form. They want you to write x in this form, p plus q root 2, where p and q are rational numbers. So as I always say, even though it's part B looks like a different question, you can always use the answer that you derive in part A. Part A, we change this 2 root 2 into 1 upon 2 plus 1 upon 4 root by rationalizing the denominator. This is from part A. We are going to use this method, this solution here, part A in here. If you want to treat this as a separate question, you need to rationalize the denominator. So you need to take 4 plus 2 root 2 and multiply and divide. You are allowed to do that, but it's time consuming. Might as well you can use this result here. So I'm going to write it as 20 root 2 times 1 by 4 minus root 2. I split them. So instead of this, these two are same. Instead of this, I'm going to use this result. So 20 root 2 times 1 by 2 plus 1 by 4 root 2. That's much easy. You don't need to rationalize the denominator because you already did that in part A. Now multiply this, you will get 20 root 2 by 2 plus, when you multiply this, 20 root 2 times root 2 by 4. So it is 10 root 2. Here all in multiplication, so you can cancel it. 5. Root 2 times root 2 is 2. So 5 2s are 10. You have 10 plus 10 root 2, which is same as this. So your P is 10. Q also 10. Q is this. This is Q. This is P. That's it. You got 3 marks for this question. From here, you can either use the result from part A, or you can treat this as a separate question and multiply and divide by 4 plus 2 root 2. You will get the same answer, which I won't suggest you to do that because we got the solution here already for this one. You can use this result in here, which will be much easier. Okay, we have finished the chapter 1. We started with indices, laws of indices, simplification and all. And then we learned about algebraic simplification, like removing brackets, factorizing the given algebraic expression. Sometimes you'll be given a quadratic function, you need to factorize it by using product sum method. Then finally we learn about surds and operations involving surds, and then rationalizing the denominator. Now what I'm going to do, I have taken 5 questions from the chapter review exercise, and I'm going to solve the 5 questions one by one. Question number 1. You need to express 27 to the power 2x plus 1 in the form of 3 to the power y. Y must be in terms of x. So you need to write the whole thing as 3 to the power something. In the 3 to the power something, 3 to the power y, the y is supposed to be in terms of x. That means basically they want you to convert the base to 3. That's it. So how do we do that? 27 is 3 cube. So you can write it as 3 cube to the power 2x plus 1. That's it. Now apply laws of indices. You need to multiply these two, 3 and this, because your laws of indices says if you have 8 to the power m to the power n, you can write it as 8 to the power m times n. So when you multiply them, you need to multiply both the terms by 3. So you will have 3 to the power 6x plus 3. That's it. This question has 2 marks. That's it. Only thing you need to know this. You can write it as 27 as 3 cube. 3 cube is 27. Then 3 times this exponent, this power. So you will get the answer already. Let's move on to question 2. Question number 2. 243 square root of 3 equals 3 to the power a. Find a. You are given this, you need to find a. 243 times square root of 3 is 3 to the power a. So the a is in here as an exponent index. So that means on your left hand side you have some number which can be written in the form of 3 to the power something. That's what we are going to do. We are going to convert this whole thing as 3 to the power something. So you can say that whatever the power is 8 equal to 8. So how do we do that? 243, right? Try to write 243 as a 3 to the power of something. If you don't know, just factorize it. 243, when you factor by 3, 8 3s are 24, 1. Then you can take it as 9 times 9. So which is 3 times 9 square. 9 times 9 or 3 times 3 to the power 4. So altogether, if you can check using your calculator, it should be 3 to the power 5. Because 3 to the power 4 is 81. 81 times 3. Times square root of 3, which is 3 to the power half. Now our laws of indices says you can add them when the base are equal. You can write it as 5 plus half, 3 to the power 8. So your a will be 5 plus half, which is 5.5. 10, 11 upon 2 or 5.5. That's it. This question has 3 marks. You just convert everything to 3 to the power of something and equate the powers. You got the value of a already. Okay, question number 3. You are given this 4x cube plus x to the power 5 upon 2 divided by square root of x. You need to write this, simplify it and write it in this form, 4x to the power a plus x to the power b, so that they want you to find the values of a and b. So how do we do that? We have 4x cube. You can put them separate. Okay, x to the power 5 upon 2 divided by, write square root of x as x to the power half. Now divide each term by x to the power half. So you will have 4x cube by x to the power half, x to the power 5 by 2 by x to the power half. Now apply laws of indices. Bring this here up. 4x to the power 3 minus half plus here x to the power 5 by 2 minus half. So which is 4x to the power 6 minus 1, which is 5. 5 by 2 plus x to the power 5 minus 1, 4 upon 2. or x square. Write it as x square. So you got this form already. 4x to the power a, your a is 5 upon 2, and x to the power b, your b is 2. That's it. This question has 2 marks. Again we apply laws of indices here. When you have a to the power m divided by a to the power n, you can write it as a to the power m minus n. That's it. Question number 4. We need to solve this equation. That's all. You need to solve this, and this question has 4 marks. How do we solve this? Okay, maybe first we remove this denominator. We bring this root 3 here. So multiply everything by root 3. It will become a root 3 plus x root of 12 times root 3 equals 8x. Here root 3 will be cancelled. So 8 root 3 plus, when you multiply this, it becomes square root of 36. 12 times 3. Square root of 36 is 6. So you can straight away write it as 6x. It's 8x. That's all. Now easy for you to find the value of x. Bring the 6x here. So 8 root 3 is 8x minus 6x, which is 2x. So your x is 8 root 3 divided by 2, which is 4 root of 3. That's it. I don't know why they have given these 4 marks for this question, but it's just easy. You multiply everything by root 3 and you got the solution already. Let's move on to question number 5. Okay, question number 5. You are given 5 divided by square root of 75 minus square root of 50. You need to write this in this form. Square root of a plus square root of b, where a and b are integers. It's specifically mentioned there in the question. A and b are integers. This question has 5 marks. Let's see how we can do that. Square root of 75 minus square root of 50. We know how to rationalize the denominator. Take the positive, square root of 75 plus square root of 50, multiply both numerator and denominator. You can do that. But you need to deal with bigger numbers. Instead, before you multiply and divide by the opposite of this, take a look at the surds first. It can be simplified. When you simplify, it will be much easier. Because 75 is 25 times, you can write the 75 as 25 times 3 minus 25 times 2 is 50. Correct? So square root of 25 is 5. So you can write it as 5 root 3 minus 5 root 2. So if you take 5 as a common factor, you can cancel them out. So you are left with 1 divided by root 3 minus root 2. This will be much easier. If you rationalize the denominator now, you need to deal with 3 and 2 only, smaller numbers only. Instead of 75 and 50, it's going to be a lot of calculations involved. So now multiply and divide by root 3 plus root 2. So when you multiply, your numerator will be root 3 plus root 2. Your denominator a plus b into a minus b. A square minus b square. Root 3 square is 3. Root 2 square is 2. So 3 minus 2 is 1. So you will have root 3 plus root 2, which is same as root a plus root b. A and b are integers. 3 and 2 are integers. That's it. That's why whenever you want to rationalize the denominator, before just jumping into rationalize the denominator, check first whether it can be simplified further. Okay. Sometimes you will have this type of questions like 5 divided by 2 plus root 3 into 3 minus 2 root 3, something like this. They want you to rationalize the denominator. Before you rationalize the denominator, you need to remove brackets and simplify them. When you simplify them, you will get a single term here. Like not a single term, you will have like only 2 terms here, something like this. Instead of 2 separate terms, you will get only one denominator, only one term. I cannot say one term, 2 terms connected by plus or minus, something like this. You will get something like this instead of having so many numbers here. So first multiply them When you multiply them, let's say you got, after simplification, let's say you got 11 minus 10 root 3 or something like that. Now rationalize the denominator. We know how to rationalize the denominator. Take the positive of this, multiply and divide, you can rationalize the denominator.